Hello everyone, welcome to the final review video. In this video, we're gonna talk about the sections we've covered since midterm 2. If you want to see the sections that midterm 2 and midterm 1 cover, you can go ahead and look at those review videos. But first, we're gonna go ahead and list off what the topics we learned since, what was that, week 8. So we started and finished chapter 10, and chapter 10 is the only new stuff that we've covered that will be on the final. So chapter 10 was on systems of equations. And the first thing that we talked about in that chapter was solving systems of linear equations in 2 or 3 variables. And the way that we started off doing these was with the classic substitution method. And we also talked about the elimination method. We were particularly interested in the elimination method because it generalized nicely to elementary row operations when we were using matrices, which was actually what we talked about next. We talked about using matrices to solve systems of linear equations. Okay, and in particular, we talked about using elementary row operations to do so EROs. And then after we introduced the idea of matrices, we also talked about matrix algebra. We also talked about determinants of matrices. And lastly, we discussed Cramer's rule. Okay, so since chapter 10 was what we focused on since the past midterm, I'm going to go ahead and do another example of solving a system of equations. So let's say we want to solve like a 3x minus y plus 2z equals -1, 4x minus 2y plus z equals -7, -x plus 3y minus 2z equals -1. Okay, so to start off, we're going to go ahead and put this bad boy into a matrix. So we'll record the coefficients of 3, -1, 2, -1, 4, -2, 1, -7, and -1, 3, -2, -1. Okay, now to start off, I want to get a 1 in this top left entry. I think the easiest way to go ahead and do that is going to be to multiply this -1 by a -1 to make it +1 and then move it up. So let's go ahead and do that. So we'll multiply this by -1, and we'll just go ahead and do that first before moving it up. So that'll get 3, -1, 2, -1. So the first 2 rows are the same, and then we flip the signs on the bottom row, so we get 1, -3, +2, +1. Okay, now I'm going to go ahead and move that 1 up. So I'm going to swap the first and third rows. By the way, you don't have to annotate the edges of matrices the same way I do. There are other alternate formats of illustrating elementary row operations. You're welcome to use those. I just use these because they make the most sense to me personally. But you're welcome to use whatever makes the most sense to you and is correct. Okay, so if we swap those two, we get 1, -3, 2, 1 on the top now. I'll move that row down to the bottom. Okay, so now we can begin the real work. We want to look at this first column. We want to eliminate that 4 and that 3. So to do so, what I'm going to do is I'm going to multiply this this top row by -4. And I'm going to add it to the second row. And then I'm going to multiply that top row by -3 and add it to the bottom row. And that should eliminate the 4 and the 3 as desired. So go ahead and do that. We get the same thing in the top row. Okay, so then we're going to get for the next row 1 times -4 plus 4, that's 0. That's what we wanted to happen. And then we're going to get -3 times -4 is +12 minus 2 is 10. -4 times 2 is -8 plus 1 is -7. And then -4 minus 7 is going to be -11. And if we do the same thing, but with -3 to the top row and add it to the bottom row, I think we get 0. And I think we get an 8. And then we get -4 and another -4. Okay. So now we're going to go ahead and look at this little chunk right here. Now you could take that second row, divide everything by 10 to get the 1 in this spot. But I think the fractions will get really, really messy because you got this -7, this 11. It's kind of gross. But if instead we were to look at this 8 and divide this bottom row by 8, we'll get 1 and then 1/2 and -1/2. That's a nicer fraction to work with. So I'm going to go ahead and do that instead. So I'm going to go ahead and I'll divide this row by 8, multiply by 1/8. So we get 1, 0, or oops, 1, -3, 2, 1, 0, 10, -7, -11, 0, 8 divided by 8 is 1, and then we get, -4/8, which is -1/2 in each of these entries. Okay, now I'm going to go ahead and swap these two rows. So now the second row becomes 0, 1, -1/2, -1/2, 0, 10, -7, -11. Okay, and now we can go ahead and eliminate that 10 by multiplying this second row by -10 and adding it to the third row. And when we do that, first row stays the same, second row stays the same, and the bottom row we get 0, and then -10 plus 10, this can be 0, which is what we wanted. And then if we do -10 times -1/2, that's 5. So 5 plus -7 is -2, and 5 plus -11 is negative. Oops. I said 2, and I wrote 7. I meant 2. There we go. And then 5 plus -11 is going to be -6. Okay. And now we want this one to be a 1. So I'm going to go ahead and multiply this row by -1/2. So dividing by -2. And when we do that, zero, 1, half, 0, 0, -2 divided by -2 is 1, and then this will be a 3. Okay, so now this is in row echelon form. You could stop here and back substitute if you so wished. I'm going to go ahead and keep going and put this into reduced row echelon form for easiest pulling the solution out of the matrix. So to put this into reduced row echelon form, let's go ahead and cancel out that -1/2 and that 2 using this 1 here. So to do that, I think I'm going to multiply the row by +1/2 and add it to that row. And then I'm going to multiply it by -2 and add it to that row to cancel those out. So let's go ahead and do that. We get 1, -3. Those stay the same because we've got 0 entries in the bottom row for those. So adding 0 to those won't change anything. Okay, so now we get 1 times -2 is going to be -2 minus 2 is 0. And then 3 times -2 is -6. This gives us -5. Okay, for the second row, we get a 0 and a 1. Those stay the same. And then 1/2 minus 1/2, that's 0. And then 3 halves minus a half, that's 2 halves. That's just 1. And the bottom row stays the same. Okay, and then the last thing I want to eliminate is I want to get rid of that -3 using this one. So to do that, I'm going to take this middle row and I'm going to multiply it by +3 and add it to the first row. And when we do that, we get 1, that stays the same. And then 3 times 1 is going to be 3 minus 3 is 0. That's good. 0 plus 0 is 0. And then we get 3 times 1 is 3, minus 5 is going to be -2. And then these 2 rows stay the same. Okay, and this is in reduced row echelon form. Excellent. And so now we can see the solution from here is we've got a 1 here in the x spot and then -2. So that means that our solution, the x coordinate is -2. We got a 1 in the y spot and a 1 over here. So that means the y coordinate is 1. And then lastly, we've got a 1 in the z coordinate and a 3 here. So that means we've got 3. So that's our solution, -2, 1, 3. All right. So there was another example of using matrices to solve a system of linear equations. I hope you found it helpful and illuminative. Keep up the good work. We're almost there. We're almost done. Once you take that final, it's summertime, baby.